Our lesson today is sequences. We have three types of sequences: arithmetic sequence, geometric sequence, and quadratic sequence. This is the main sequences we have in this syllabus. If we have sequence like that, 3, 5, 7, 9, 11, and so on. What is the rule for this sequence? Add 2. We need to find the nth term. We need to find the nth term for this sequence. Nth term means the rule you can find if you substitute n by 1, you get the first term, n by 2 gets the second term, and so on. How to find the nth term for this sequence? Because we add 2 every time. Add 2. So we can find the sequence. If we add a constant number, we subtract a constant number, this is called arithmetic sequence. For the arithmetic sequence, we have a rule, but we can find by easy way. If you add 2, for example, so 2 times n, this linear sequence. So 2n, 2 plus what? Equal 3. So 2n plus 1. This is the nth term. So 2n plus 1. And you can check put n equal 1. 2 times 1 plus equal 2. 2 plus 1 equal 3. Put n equal 2. 2 times 2, 4. 4 plus 1 equal 5. Second term. Put n equal 3. 2 multiplied 3, 6 plus 1, 7. So this is correct. So when we add 2 every time, so 2n plus this number, how to find this number? 2 plus what equal 3. 2 plus what equal 3. So 2 plus 1. Or go one step to the back. From 5 to 3, subtract 2. So if we subtract 2 from 3, so we have 1, so this number 1. The other way to find the nth term, we have a rule for the nth term. If we have arithmetic sequence, A stands for the first term, plus n minus 1 into D. D, this number we add or subtract each time. A stands for the first term, D for the difference between the terms, the number we add or subtract every time. So if we apply this rule, the first term 3 plus n minus 1, we multiply, we add 2 every time, so the common difference between them 2, so 3, then 2 times n equal to n, 2 times negative 1, negative 2, so we get the same answer, which is 2n plus 1. This using the rule. By the same way, if we have similar one, for example, 17, 14, 11, 8, and so on. What is the rule for this sequence? Minus 3. Minus 3. 17 minus 3, 14. 14 minus 3, 11. 11 minus 3, 8. So this arithmetic sequence, because if we add or subtract same number, this is called arithmetic sequence. Okay? Arithmetic sequence. So the nth term, take this number and multiply by n. So negative 3 times n, so negative 3n. Then negative 3 plus what equals 17? Negative 3 plus what equals 17? So or 17 minus negative 3, which is 20. Or go one step to the back. 14 minus 3, 14 plus 3 equals 17. So 17 plus 3 equals 20. So this number 20. Go one step to the back. Because when we go back, add 3. 8 plus 3, 11. 11 plus 3, 14. 14 plus 3, 17. So if we add 3 for 17, we have a 20. This is the zero term. This is the number should be written here. So negative 3 plus n. And also you can check your answer. Put n equal 1, you get 17. N equal 2, you get 14. And so on. And also you can use the rule. The nth term is A plus n minus 1 into D. A stands for the first term, 17. D, the difference between the terms, which is negative 3 here. If you simplify, you get the same answer. Negative 3 times n, negative 3n. Negative 3 times negative 1, positive 3. So 20 minus 3n. Or negative 3n plus 20. So by the rule, you can get the answer. So this is the rule for arithmetic sequence. So this is the first type of sequence, arithmetic sequence. We add or subtract a constant number. The second type of sequences, if we multiply by the same number. So for example 2, 6, 18, 54, and so on. What is the rule for this sequence? Multiply by 3, multiply by 3, okay? Multiply by 3 each time. This is called geometric sequence or geometric progression. For this sequence, we have a rule. The nth term equals A stands for the first term also, R, which is the number you multiply each time, power n minus 1. So in this case, we have 2. This is the first term. And R, we multiply by 3 each time, so multiply by 3, power n minus 1. And you can check your answer. Put n equal 1, so 3 power 0, which is 1, 1 times 2 equal 2. If you put n equal 2, you get 6. If you put n equal 3, you get 18, and so on. So the rule, if you multiply by the same number each time, the rule A R power n minus 1. A stands for the first term, R stands for the ratio between the terms, the number you multiply each time. This is called geometric sequence. The last one, the third one, is the quadratic sequence. Quadratic sequence. For the quadratic sequence, the simplest one, like this one, 1, 4, 9, 16, 25, and so on, 36. 1, this means 1 squared. 1 times 1 equals 1. 4, 2 squared. 3 squared, 4 squared, 5 squared, 6 squared. So each time we square the number. So if we wrote the numbers, this 1, 2, 3, 4, 5, 6, we square the numbers to get this sequence. So the nth term for this sequence equal n squared. Because if I need the first term, 1 square. If I need the second term, 2 square. Third term, 3 square. So the nth term for this sequence, n squared. Sometimes we start this sequence from 4, 9, 16, 25, 36, and so on. In this case, what is the nth term? We skip the first term. In this case, because we start from 2 power 2, so the nth term in this one will be n plus 1 all squared. In a similar way, if we start from 9, 16, 25, 36, and so on, so the nth term, n plus 2 all squared. Sometimes it's not easy like that. For example, if we have sequence like that, 10, 28, 56, 94, and so on. We need to find the nth term for this sequence. I need to find the nth term for this sequence. First, do we add same number each time? 10 becomes 18, 28 becomes 56. So we don't add the same number. Do we multiply by the same number? No, because 28 divided by 10 is not equal. 56 divided by 28. So we don't divide or multiply by the same number. So this sequence, not arithmetic sequence or geometric sequence. Now, to find the nth term for this sequence, find the first difference. 94 minus 56. Can you find 94 minus 56 using your calculator? 94 minus 38. Now 56 minus 28. 28. 28 minus 10. 18. So the first difference is not constant. So this sequence is not linear. Find now the second difference. 38 minus 28, 10. 28 minus 18, 10. The second difference is constant. If the second difference is constant, this quadratic sequence, and the nth term in this case, the nth term will be a n squared plus bn plus c. So we need to find a and b and c. Okay, we have rules to find a and b and c, and also we have we can solve by another way. The first, if we need to use the rules, so 2 times a equal second difference, okay, and 3a plus b equals the first difference, and a plus b plus c equals the first term. If we apply these rules now, if we solve this equation, 2a equal the second difference equals what? 10. So can you find a? Divide by 2. So a equals 5. Now 3a plus b equals the first difference. Look, this is the second difference, first term. Okay? Now 3a plus b equals the first difference. So 3a plus b equals the first difference, which is 18. But we have a is 5, so 3 into 5 plus b equals 18. So 15 plus b equals 18. Then we can find b. b equals 18 minus 15, which is 3. Now b equals 3. Now to find c, a plus b plus c equals the first term. A plus b plus c equals the first term. We have a and b, so we need to find c. First term, which is 10. So a, which is 5, plus b, which is 3, plus c equals the first term, which is 10. So 8 plus c equals 10, so c equals 2. Now the nth term for this sequence, the nth term equal an squared, so 5n squared, plus bn, so 3n, plus c, which is 2. This is the nth term for this sequence. 5n squared plus 3n plus 2. And you can check your answer. Put n equal 1, get 10. Put n equal 2, so you have 28. Also, you need to know the sequence of cube numbers. So this sequence 1, if we cube of 1 and cube of 2 and cube of 3 and so on, cube of 4, cube of 5, this will be 1, 2 power 3, which is 8, cube of 3 27, cube of 4 64, cube of 5 125. So this sequence is called the sequence of cube numbers. The nth term for this sequence, n power 3.